Hello there. Today I'll be starting a new series called Neetcode150. It is a series that was inspired by the code found by Neetcode. I think many of you who do algos probably have seen his videos. And the benefits of this list is to make sure our fundamentals are sound and we build up our concepts. Rather than going through the random videos that we used to go to, in addition to those, that one random question a day, we're going to be going through this list to make sure, tidy up my fundamentals. And so today we're going to be starting with contains duplicates, and we will go through all of the easy problems for all of the topics, following the medium problems and then the hard problems. And we'll be done with 150 neat codes. All right, perfect. Without further ado, let's begin with the contain duplicates. Actually, I make this it's only a minute long, so let's just go for it. Okay, so containing duplicates, this problem, given the integer array's nums, return true if any value appears twice in the array, and return false if every element is distinct. So let's look at some of the possibilities, what's going on here. And the numbers, example 1 is 1, 2, 3, 1, so it's true. 1, 2, 3, 4, false. And you have 3 1s, 2 3s, 4, so on and so forth, and you return true. So earlier, I remember a problem that I've done about containing duplicates, where all the numbers, are consecutive, and there's just one duplicate number, and we're trying to find out what that was. And we could do an O of 1 space because we could add up all the numbers from 1 through that particular n and find that extra number. But in this case, we can't do that because we have multiple duplicates of any number of any order, so we don't know what it is. So there are several ways that we can do this. One of the most fundamental ways is creating a set and making sure that all the numbers have not been seen in the set. And if there is a number that's been seen in the set, then we just return true. Another way to do this is to create a counter, and that's the simplest way of doing this. It's to use the counter data type to create the frequencies. If frequency is greater than 1, then true. Also, another way to do this is to use to just determine the length between the set and the list. Are they equal? If they're not equal, then it's false. If it's equal, then it's true. There's no way around that. I don't recall. Let me just check one more thing. Let's see. Did I forget anything? I don't. Oh yes, there's this one very bad method that is that should be slower than all these methods, and that method is called sorting. If we sort the array and then we count, we look for if the previous or the next item is equal to the current item, then and check current first equal to next and return true. So those are the 4 methods that I can think of, and we're gonna start with the first one. Okay, so first thing first, we're gonna create a scene set if for num in nums, if num in scene, return true, capital T. Else, we're gonna just add the item to the scene, so scene.add num, and return false otherwise. So that's our first solution. Let's run the code. Alright, and submit. Okay, so not bad. That's 1. Alright, let's do number 2. So frequency counter equals counter of the set. I mean, not the set, nums. And so for num and frequency in counter, not items, if frequency is greater than 1, return true, else return false. Run, submit. Alright, done. Okay, this one's pretty quick. Return the length of the set of the nums equals length of nums. Alright, run code. Oh, oh, no. Does not equal. There we go. Alright, return. Alright, great, done. So, and the last one. So the last one is the sorted list. So nums not sort. For num in nums. Well, actually, no. For I in range lang nums. If nums I is equal to nums I plus 1, return true. Return false. Of course, we need to make sure we don't go to the end of the list. We go 1 before the end of the list. And that's it. We have solved the problem. Funny enough, the sorted problem, which is supposed to be the slowest, the n log n method, is the fastest. It is also saves the most amount of space. This is a O of 1 space, sacrificing space sacrificing space for time. And in other methods, it's a n O of n time and O of n space. So that is all for this particular problem. We just basically stomped through this problem pretty quickly, and we have 4 solutions. Well, if you have any questions, please leave them in the comment section below. If you enjoyed the video, please like and subscribe. And if you want to see more of my videos, please wait, did I say that already? Check the link in the description below. And thank you very much. Have a good one.